This is problem number 2 for the SOA's release questions for exam FM, and it really does serve as a barrier to entry for the rest of the exam. If you can't do this problem, you aren't going to be able to do anything else. So much of the test, probably 90%, is based on geometric series and summing geometric series and working with geometric series. So let's have a look at it. I've written out everything we need here. The function or the little formula we're going to use to sum up the geometric series is this right here. We take our first term minus our first omitted term and divide that by 1 over the 1 minus the growth rate. And in this particular problem, we have somebody who's making deposits every 4 years, so $100 deposits every 4 years for 40 years. And then the amount X at 40 years is 5 times that of 20 years. So I've written out the chain of deposits right here. We make one deposit of $100 at the very beginning, and that earns interest for 40 years. 4 years later, we make another deposit that earns interest for 36 years. 4 years after that, we make another $100 deposit, and that earns interest for only 32 years, all the way down until we make our last deposit, which will only earn interest for 4 years. So, in a lot of ways, this is backwards, right? Usually when we're looking at a geometric series, we're counting up. So we'll consider this the first term, even though it's on the end, and this the last term. So, in order to solve this problem, we're going to write out 2 different series. We need the sum of the value of the account at 20 years and the sum of the value of the account at 40 years, because the amount X at 40 years is 5 times that at 20 years. So we're going to use those 2 sums to write an equation, and we're going to solve that equation for 1 plus I. So the first term for the sum of our payments after 20 years is 100 times 1 plus I to the 4th minus the first omitted term. So if we were to go beyond 20 years, what would come next? That would be this term right here, over 100 times 1 plus I to the 24 over 1 minus the growth rate. And what's the growth rate? Well, it's 1 plus I raised to the 4th power. We keep multiplying, we keep compounding interest in 4-year chunks. So 1 minus 1 plus I to the 4th. Now we're going to do the same thing for summing up the balance of the account over the entire 40-year period, which is the end of the problem, what we want to solve for. So we have the first term again, 100 times 1 plus I to the 4th minus the first omitted term, which isn't actually present here, but if we were to keep compounding in these 4-year increments, the next term would be 100 times 1 plus I to the 44th. And again, we're going to divide that by 1 minus the growth rate of 1 plus I to the 4th. Now, with this statement and these 2 geometric series, we can write and solve an equation. So the amount X after 40 years is equal to 5 times that of 20 years. So X equals S sub 40, which is equal to 5 times S sub 20. The sum of the series at 40 years is equal to 5 times the sum of the series at 20 years. So we could solve that by dividing both sides by S sub 20, which means we're going to divide this fraction by that fraction. And of course, when you're dividing fractions, it's the same as multiplying by the reciprocal, which means these 2 denominators are going to cancel, and we are going to be left with 100 times 1 plus I to the fourth minus 100 times 1 plus I to the 44th over 100 times 1 plus I to the fourth minus 100 times 1 plus I to the 24th. And there's more cancellations that we can do, right? We could factor out this 100. And in fact, we can also factor out a 1 plus I to the fourth, because every term in both the numerator and the denominator contains this term right here, 100 times 1 plus I to the fourth. So we can cancel our hundreds, and then we can cancel these as well, leaving us with 1 minus 1 plus I to the 40th over 1 minus 1 plus I to the 20th, and still equal to 5. Now, as you're going through exam FM, anytime you find yourself in a position where you're doing lots of algebra and you come up against exponents that are multiples of each other, so 40 is 2 times 20, there's a real good chance that you are on the right track. The exam writers absolutely love to create situations like this where you have to do a U substitution and then write a quadratic and solve the quadratic in order to get your final answer, which is what we're going to do here. So multiply both sides by 1 minus 1 plus I to the 20th gives us 5, and I'm going to go ahead and distribute that 5, minus 5 times 1 plus I to the 20 is equal to 1 minus 1 plus I to the 40. And now we're going to write a quadratic by getting all of our terms on the same side. So I'm going to add 1 plus I to the 40 to both sides, and I'm going to subtract 1 from both sides. And then I'm going to reorder my terms just a little bit. So adding 1 plus I to the 40, bring that 1 out front. 1 plus I to the 40. Going to leave this minus 5 times 1 plus I to the 20 alone, and then I'm going to subtract 1 from both sides. 5 minus 1 is 4, so I'm going to have plus 4 equals 0. So really just algebra 2 level stuff, creating a quadratic here. And because our exponents are multiples of one another, we can do a little U substitution here. Let's say that U is equal to 1 plus I to the 20. That means U squared is going to be equal to 1 plus I to the 40. And that means we can write a quadratic, U squared minus 5U plus 4 equals 0. Very easy to factor. U minus 4 times U minus 1 equals 0, which means our values of U are either 4 or 1. So let's get the non-solution out of the way first. Suppose U is 1. So we could come over here and we say 1 is equal to 1 plus I raised to the 20th. Just plugging in that 1 for U, using our substitution here. And we want to solve for 1 plus I, because that's really the goal. This 1 plus I construction here is our unknown. It's our variable. We could solve for I itself, but in order to find the total amount in this account, we're going to end up plugging in a value for 1 plus I in interest rate. So we're just going to treat 1 plus I in parentheses, like that's our variable here. So we take the 20th root of both sides. This calculator, still very handy on this exam. Take the 20th root and you get 1 equals 1 plus I. But look what happens if we were to plug that in right here. we'd have 1 minus 1 to the 4th, and of course 1 to the 4th is 1, so we get 1 minus 1 is 0. We can't divide by 0, so u equal 1 is not a valid solution. But what if u is equal to 4? Okay, so 1 plus I raised to the 20. We can take the 20th root of both sides here, and we will get that, write it over here. 1.0718 or thereabouts is equal to 1 plus I. So take the 20th root of 4, we get this guy right here. That's a pretty meaningful interest rate, and it certainly looks reasonable. So the last thing we're going to do is solve for x, the amount at 40 years, now that we have a value for 1 plus I. So the value of the account at 40 years is this expression right here. So let's substitute. We have 100 times 1.0718 to the 4th minus 100 times 1.0718 to the 44th over 1 minus 1, 1.0718 to the 4th. And if we churn all of that into our calculator, we will get 6194.72 or thereabouts, which rounds up to 6195, or E for the final answer. So, very challenging problem, but also very fundamental to what we're doing on this exam. So if you can get a handle on this particular problem, you get comfortable with this formula, you understand why this chain is what it is, and you can work with it without having to write out every term, and you can just go to these expressions right here. From there on, it really is just algebra. So there you have it. Study this one, do it backwards and forwards several times until you're comfortable and confident. It's going to make the rest of the exam quite a lot easier.